Okay, first one. What do we got?
A,
Okay.
A plus B, A minus B.
It is. Very good. Okay, second one. What do you think? Ellie, remember that one? Oh, so A squared plus B squared. Good.
Yeah.
A squared. That one doesn't change. Very good. That's the tricky one. Okay, how about the next one? Bailey.
A minus B.
Good.
A squared plus AB minus B squared.
Remember, the last one's always going to be a plus. Never changes. Okay, what about the sum of cubes? Last one. Cyrus.
A plus B
Times.
A squared minus AB plus B squared.
Good. Very good. Okay. So let's just try a couple problems with these, right? Here's kind of where we left off yesterday. So what about something like this? Now let's think about this in terms of a strategy, right? So we're eventually going to move up to bigger types of problems, but we're starting off today. We're only dealing with two-term factoring problems. So these are going to be the ones where the only possibility is going to be a sum or difference pattern, but we always want to try to do something first. What's that going to be? What is it that we're always trying to do first? Before we go any further. Well, okay, I mean it's this one actually isn't equal to 0. We're just trying to factor this one, but there's still something else that we want to think about here. Greatest common factor, right? So Brandon, can I take out a greatest common factor here? Could I factor out any power of x?
No.
Can't. You're right. Is there any number that goes into 8 and 125?
4.
I don't think so. 4 doesn't go into 125 because it's odd. So I don't think there is. 5 won't go into that one because it won't go into 8 because it doesn't end in 0 or 5. 8 doesn't work either.
2.
Okay, let's no. Let's talk about this just a little bit. Instead of throwing numbers out, let's just think about what are the ones that could possibly work. And there aren't any this time. But could an even number ever divide into an odd number?
No.
It cannot. An even number can never divide into an odd number. Now, an odd number could divide into an even number, right? 3 goes into 6, but we could never find an even number that divided into, say, 11, right? Or 13, or 15. Never going to be an even number. Only odd numbers could, right? Does that make sense? Okay. So we know that we're pretty limited here. There is no odd factor of 8, and so there can't be a common factor, can it? Right? So we're stuck with that, but that's good. It just means we can skip that first step. Now we've got to decide which of our 4 factoring patterns, if any, could this potentially fit?
Isn't the A squared minus B squared?
A squared minus B squared?
Yeah.
Why squared?
Well, it would be cubed.
Cubed, right. Okay, good, it'd be cubed. Because I've got an x cubed in the first term minus something, does it make sense that the only possible fit is going to be a difference of cubes? It may not work, but that's the only possible fit, right? So let's just see. Let's write that one out. So what's that going to look like if we do a cubed minus b cubed? What's the result? You already told me once. Everybody, what is it?
AB to the 6 to the
A minus b times plus ab plus b squared. Good. Okay. So then for us, we just have to decide, okay, it's a difference of cubes. So first of all, could I write this as a difference of cubes? Could I write the first term as something cubed and the second term as something cubed? If I can, that's going to work. I'm just going to follow that pattern. If I can't, well, nothing's going to work. What about the second one? Is 125, is that something cubed?
Possibly.
Yeah.
What is it?
Is it 5?
5. It is. So that's telling us that b is 5, right, in our pattern. What about the first one? And this is the tricky one. What could I cube and get back the answer 8 times x cubed? And you kind of have to think about this in terms of, I'd have to distribute the 3 to both parts to make that happen, right? So it looks something like, when I distribute the exponent to the number and the variable, I would get those 2 parts, 8 and an x cubed. 2 and an x, right? Everybody see that? Because 2 cubed is 8 and x cubed is x cubed, right? Okay, so now we got a match. We know that our a is going to be replaced by 2x and our b is going to be replaced by 5. Now we just follow the pattern, right? That's it. So the little factor is going to be what? 2x minus 5. Yeah, right? Okay, the big factor is going to be what squared? Yeah, and you gotta be careful with this. The most common mistake that people make here is they put down the answer 2x squared, but that's not right, is it? Because that's really not what's going on. What's really going on is it's gonna be the quantity 2x squared, right? Because a is equal to 2x. And what's that give us instead? 4x squared, right. Everybody see that? Because we have to distribute the 2 to both parts, right? The power of 2. So we're going to end up with our first term being a 4x squared. That, if you're going to miss this one, that's where it's going to be, guaranteed. And then we get a plus, and what's the a times b going to look like? 10x, yeah. 2x times 5 is 10x, and then plus b squared is 25. 5 squared would give us 25. Okay, here's the other question from yesterday. We didn't talk a lot about this, but we always have to ask ourselves, okay, this one's done. It's linear. The x is not taken to any power. This is a quadratic factor. Could that one be factored anymore?
Yeah.
It looks like it might, but remember with our patterns what we said. We said that when we do the sum or difference of cubes, we end up with the quadratic, the big factor that we get from that pattern. The big quadratic factor is always done. It's what we call an irreducible quadratic factor. You can't go any further with it, right? So it's done. So we don't have to worry about it. That's our answer, right there. That's what we input. It's broken apart.
So you do input the 2x cubed minus 5 cubed.
No, you don't have to. No, that's part of the work. All we had to do, all this is for, is just to tell us, remember, all this is just saying, okay, what's our A and what's our B, so we can follow that pattern, right? Okay? Okay, one more, I'm gonna let you work. How about this? Whoa.
That is like, oh my mustard.
No, this one looks worse than it is, right? Because this is one we're gonna be able to make a lot easier, all right? What's the first thing we always wanna try to do? Okay, greatest common factor, good. Okay, Caitlin, do you see, first of all, what power of x could I undistribute? Caitlin, does that make sense? An x squared? And we're always trying to find, remember, what we're trying to find is, if we look at all the terms in the factor that we're trying to take the greatest common factor out of, right, the expression, then whatever the weakest power of x is, that's going to be the one that we can factor out. And if there is no x in one term, like in the last example, we can't factor any x's out, right? So in this one, we got an x squared, so that's part of it. Now, what about the number part? This is a little tricky. These are big numbers, right? But we got to go back to some number sense stuff, which goes all the way back to, like, grade school and middle school kind of stuff. So what can you tell me about the number that I'm factoring out? What's the sign going to be? It's going to be negative because the leading term is negative, okay? What about the magnitude? What's a number that divides into both of those two? And we may not get the full meal deal the first time. We might take part of it out and then figure out that there's another one we can factor out and multiply by that. But what's one number for sure that's going to divide into both of those?
2.
Not 2, because that's odd, right?
10.
7.
4.
Well, now don't just throw numbers out. I don't want you to guess. I want you to give me an answer that you can support. What is it?
4.
Well, 4 is not going to work either because that's odd, right? 4 is even.
Is it 3?
It's 3. And how'd you get that?
Because if you add them all, it's
very good. Okay, if we add the digits up, when you have really big numbers, if you add the digits up, remember that if what the answer you get is divisible by 3, then the great big number is also, right? So 6 plus 4 plus 8 is what?
18.
Does 3 go into 18?
Yeah.
It does. So therefore 3 also goes into 648. What's 3 plus 7 plus 5? 15. Does 3 go into 15? So that's also divisible by 3. So we could take out a negative 3. And then an x squared. Well, let's figure out what's going to be left over when we do that. I want to show this to you in a little different way. But this is a really good way, because I think this helps you get a little extra insight into this whole factoring process. We may have done this once, but let's do it again. If I want to know what goes there, I'm just going to divide the first term by the greatest common factor. Right? Okay, what's that going to give us? That's supposed to be next to the 5th.
212.
Uh,
No, wait. 200.
okay, well, what can you tell me? Negative over negative is positive, so those go away. X to the 5th over x squared is
X to the third.
x to the 3rd. So we know we're going to get an x cubed. But what's the number part going to be? Well, let's see. 3 goes into 6 how many times? 2. So the hundredths digit is a 2. 3 goes into 4
One.
once with 1 left over. And you're right, it's going to be 216. 3 goes into 18
6.
6 times. So the first term is going to be 216x cubed, because that's what negative 648x to the 5th divided by our greatest common factor of negative 3x squared is going to be, right? Okay, so what's going to go there? How am I going to tell? Do the same thing. Whatever negative 375x squared divided by my GCF is. Negative over negative is
Positive.
positive. What happens to the x squareds?
They cancel out.
They cancel. So 3 goes into, we get a plus.
So you get
3 goes into 3 once, 3 goes into 7 twice with 1 left over, right? And 3 goes into 15
5.
5 times. Okay, everybody see?
What do you do with that number 1 over then? Do you just leave it alone? The one that's left over?
Well, right here you mean?
Yeah.
That one? Well, that's just my short way of doing long division, right? If 3 goes into 7 twice with that 1 left over, and 3 goes into 15 5 times.
Okay.
See how that works? Okay? So then, where to go from here? So let's take this and go to the next page. I want to leave all this stuff on there, so when I put the notes up online, it's all there. Okay, so now what? I've got it broken down a little bit, but can I go further? I took out a greatest common factor. What's left looks more promising. How many terms are there in this factor? 2. So if I'm trying to factor a 2-term expression, what are my options? I mean, I got sum squares. I mean, I got 4 options, right? The sum and difference patterns. Which one could potentially work here?
Adding.
Adding sum of what though?
A squared.
Squared?
Cubed.
Cubed, right? Because I've got a cube there, right? So the one that could potentially work, and let's audition this one, see if it works. The one that could work would be a cubed plus b cubed. If it does, what's our pattern? What does that factor into?
A plus B. A
Sorry.
squared minus AB plus B squared.
Okay, so what have we got then? So out front, we've got this negative 3x squared, but could we write what's in the red parentheses as a sum of 2 things cubed? The second thing is what cubed? 5. Okay, what about the first one? what could I cube to get back 216 for the number and x cubed for the variable? What's the cube root of 216, do you think? No. Cube root of 8 is big, real big. 4 cubes is only 64.
So
They grow
it's
pretty fast.
6.
It's 6, yeah. So 6x, right? Okay, so our A is 6x, our B is 5, and now all we gotta do is follow that pattern, right? So what's this gonna end up being if we expand it out using that pattern, we factor it out using that pattern, sorry. What's A plus B gonna look like?
6x plus 5.
Okay. Now, how about this one? Here's where we gotta be a little bit careful. Brandon, what am I squaring?
6x.
The whole thing 6x, right? So I'm gonna do the quantity 6x squared. What's that gonna give me if I distribute the power? Not 12, because I'm taking it to that power. So 6 squared would be 36. So 36x squared, and then minus, it looks like A times B, what's that gonna be? What's AB? 30x. And then plus B squared, that's bad plus, 25. So that's what we get just from this part. So what's our answer gonna look like then? So our answer is gonna look like, well, we've got this negative 3x squared out front, that's our greatest common factor. But this part right here broke up into, by the sum of cubes pattern, it broke up into the quantity 6x plus 5 plus the quantity 36x squared minus 30x plus 25. So that's it. Okay, make sense?
Yeah.
All right, how about it? You may work.
May I use the restroom?
Yes, you may.